Let us discuss Prim's algorithm. Prim's algorithm is a greedy algorithm, always picks the smallest weight edge available at each step, aiming for a local optimum in hopes of finding a global optimum. Now, importing the heap queue module. This module provides an implementation of the heap queue algorithm, also known as the priority queue algorithm. Defining Prim's algorithm function. This function takes a graph and a starting node as input and returns the total weight of the minimum spanning tree and the edges including in the MST. Now initializing variables. V is the number of vertices in the graph. Visited is a list to keep track of visited nodes. Priority queue is initialized with the starting node and a weight of 0. MST weight keeps track of the total weight of the MST. MST edges store the edges included in the MST. Processing the priority queue. The loop continues until the priority queue is empty. The smallest weight edge is popped from the priority queue. If the node U is already visited, it is skipped. Otherwise, the node is marked as visited and the edge weight is added to MST weight. This edge is added to MST edges. All adjacent nodes of U that are not visited are pushed into the priority queue with their respective edges. Now defining build graph function. This function takes the number of vertices and edges as input and returns the graph as an adjacency list. Reading edges from user input. For each edge, the start vertex U and end vertex V and weight W are read from user input. The edge is added to the adjacency list for both vertices U and V. Now we will execute main program. Reading the number of vertices and edges. Now we will execute this code. Enter the number of vertices 4. Enter the number of edges 5. Enter start vertex 0. Enter end vertex 1. Enter the weight of the edge 10. Now we will continue until the last. Now the final output is MST weight is 19, MST edges are 0, 0, 3, 5, 2, 4, 1, 10.